Okay. First reminder, Friday we have an exam. And please bring your calculator. Be sure you have your calculator. You cannot share calculators and you cannot use your cell phone. In fact, on the exam, I want the cell phones not even on the desktop. Okay, I want them in your backpack, on the floor. Not even only thing on the desktop, please, is your exam, which will be in two parts. Your calculator, and of course pencils and whatever. I do not recommend taking math tests and pen. But some people, you don't make as many mistakes as I do, I guess, right? It's not true. Not true. Fake news. Right? I recommend pencils. The things that you can count on being there, and I underscore again that everything we've covered so far, with the possible exception of some of the complex number stuff, is had better be review. Right? It better be a review for you. If it is not review, I mentioned what you need to do. Okay, that means you're facing a headwind that is going to take extra effort to overcome. Right. The second thing is there's nothing that replaces graphite to paper. That is the big equalizer. Graphite to paper. These are the subjects that we've covered, and you can count on every one of them being there. You can count on every one of them being there. You can count on every one of them being there in some form, at least once, some multiple times, at least once, some multiple times, at least once, some multiple times on Friday. Right. The notes are a good place to start. The class slides. By the way, all the class slides are up on Canvas. Just a reminder, as somebody asked me, they said they knew where those were. I don't know if it was this classroom, I can't remember. But over, see on Canvas, right here under Files, there are class notes right there. Okay, here are the class notes. These are the written notes for every day of the week, right? Or every day that we've met, right here. And by the way, they're in alphabetical order, not chronological order. Right now, they happen to be alphabetical because F comes before J or after J. Actually, they're not in alphabetical order. Look at that. So you got to look for them by date, okay? But normally, the most recent will be at the top. All right. Then the other thing I want to remind everyone of is if you need to see any of the videos, right here is a link to the YouTube video playlist right here, okay? Also, here are some links to different things we've covered. These are some of the key concepts of chapters R1 and 2 you might find useful for the exam, right? Some review. These are videos from other places, links to other places, in addition to our class links, okay? So I mentioned last time, lots of problems in the book. At the end of every chapter, there's a review test. The answers for which are in the back of the book, all of them. All the answers are in the back of the book, right? And I believe it's cumulative. I believe the chapter, there's a cumulative review as well. Anyway, my point is lots of problems to work in the book. So from there, let's get to our today's events. Did I mention these are the things you can count on seeing on Friday? Oh, by the way, one more thing. One more thing, Deb. The test on Friday will be in the form of two parts. Part one is without your calculator. Part two is with your calculator. All right? Very simple rule. You can work on the whole test without your calculator. You can work on both parts. But be sure you're absolutely positively done with part one, the no calculator part, when you bring your calculator out. Because once you bring your calculator out, you're done with part one. You can't go back and forth using your calculator or not. No, we can't do that. right? So finish part 1 entirely. You can work on part 2 without your calculator. In fact, there will be stuff on part 2 that you can do without your calculator. I'd encourage you to have a look at it, and you can do a lot of it without your calculator. But there will be stuff on there that you can only do with a graphing utility. All right, so you're going to finish part 1 completely before you take out your calculator. If you do take out your calculator, you're done with part 1 completely. All right, you can't go back to it. All right, so that just keep that in mind. Of course, I'll remind you. All this is written at the top of the test too. This is written at the top of the test, and so you're responsible for what's up there. Another thing is when you use your calculator, when there is work that you're plugging into your calculator, and I know when there is and when there isn't, right? In other words, you might have it in one part, and then what you do up there for your calculator might apply to successive parts that you don't need extra work for, right? I understand when you can do it off of what you have on the screen. My point is, write on your paper supporting work for what you did on your calculator. If you plugged an equation in, you're solving an equation, that equation I want written on the test, right? And many times we worked up to an equation and solved the result on the calculator. All right. So avoid answers that don't have supporting work. Show your work is at the top of the test. Okay, any questions? Right? 9 o'clock. I'll probably be here a few minutes early on Friday. Probably have the test printed off. If you can get here a couple minutes early, do that. Another thing, I'm not responsible for chapel. If you have chapel at 10 o'clock, right, you need to leave accordingly, okay? I don't care if people work a little bit extra. Nobody can work for 2 hours, all right? But I don't care if people, if somebody, works till 5 up or whatever like that. But you're responsible for chapel. What's not going to happen is you come back later in the day to finish it. You're going to finish it all in one sitting. Right? That's very important. Right? All right, moving on. Any questions on that? Let's see here. Okay. Chapter 3. Now, chapter 3 starts off very, very familiar. But in my view, chapter 3 starts the college part of college algebra. Chapter 3 starts the college part of college algebra. It's going to start with more review. All right. It's going to start with more review. But we're going to get into some stuff that if you're weak in the basics, when we get into sections 4, 5, 6, if you're weak in the basics, you're going to get rolled. You're going to get completely, you're going to think that you got hit with a snowplow. All right. Don't fall behind. And I say, I'm like a broken record. If you need to go back and review, go back and review, because it's not going to work otherwise. It won't work. I'll help you review. I've done review in class, but I'm not going to do a lot more. Just what's in the slides. All right. So quadratic functions. Here's what we're going to do. Graph this. Now we know how to graph this with the calculator. We can get a pretty good idea how to graph this without a calculator, right? We can find intercepts, for example. Okay. We can read the y-intercept right off of here. The y-intercept's -3, right? The constant term in a polynomial function is always the y-intercept, right? We're going to do this a different way, and this is one of the reasons why we did completing the square, which, by the way, this will be a review for the exam. This part will be, okay? So what I'm using a basic function to review and bring together a bunch of graphing techniques that we've already had. That's the purpose of this problem, all right? It's the purpose of this. It's not just to graph a polynomial function or a quadratic, which, by the way, you need to know how to do, all right? We're going to complete the square. It's over here. Complete. square. All right. So let's see. How do you do that again? Well, the first thing you do, f of x equals. Now this is a little different because we completed the square last time on a quadratic equation. So it wasn't a function. Here's a function. You put in a value of x and you get a y, that kind of thing. We did it on this kind of thing equal to 0. Right? That's how we completed the square in the last chapter. But you complete the square in a similar fashion here. And that is you factor the leading coefficient, 2. It's a lot easier when there's not a when the leading coefficient in front of the x squared is a 1. Those are easier, right? But if it's a 2, you factor a 2 off of the x terms, and we're going to stick this minus 3 out here. Okay. Now, when you factor the 2 off of the x squared, you get an x squared. You factor the 2 off an x, what do you get? You factor 2 off an x, 2 times whatever's in front of the x has to equal 1. Because you remember when you multiply this back, you need to get what you started with. When you multiply this back, you need to get what you started with. So 2 times whatever's here needs to equal that 1 right there. Right? So this is plus, what do I have to multiply 2 by to get a 1? A 1/2. Okay, everyone see that? A 1/2. Now, this is your setup to start completing the square. You can only complete the square on expressions that have a 1 in front of the x squared term. That's why we factor the 2 off, to get rid of the 1. So we're going to complete the square inside the parentheses. Now I'm going to do something. You may or may not want to do it yourself on your paper, but I'm going to do something just for unity's or continuity's sake. I'm going to repeat that because I want this to be in the notes without any further work. We're going to mess this up. This right here, we're going to do some stuff. It's going to look messy. So I want that one there, that top line, this line right here. I want on your paper clean. All right. Now all we did there was rearrange the furniture. Everything's done here. We just rearranged the original function. So now we're going to complete the square. How do you do that? You take half of this coefficient. You take whatever's there, happens to be a 1/2. So you're going to multiply whatever's there by a 1/2. And in this case, you get a 1/4. Remember that number. So whatever's there, if it were a 3, you would have 3 halves right here. You see what I'm saying? You multiply whatever that coefficient is by 1/2. Then over here, you're going to square it. So you square 1/4, you get 1/16. And that guy goes right back in there. It will always be positive. This 1/4 could be negative. Because if that 1/2 is negative, up here, that coefficient is negative, you're going to get a negative here. So now the 1/16 goes back into our equation like that. All right. Now, okay, any questions on what we just did so far? Half of this coefficient gives you a 1/4, square it, gives you a 1/16, that goes in there. Now, I told you in this first step that we rearranged the furniture. We rearranged the furniture. This time, we changed the furniture. We brought in some new furniture. We brought in a 1/16. So now we have changed this function. Up till here, if I would have plugged in 5 in the original equation and 5 in this one right here, I would have gotten the exact same resulting value. Now, with that 1/16 there, things have changed. So I have to compensate. Remember I told you algebra comes from the Arabic word to rejoin, to realign, to complete, right? It's the word used in Arabic for bone setting. So now our bones are out of line because we put the 1/16 there. So I'm going to have to subtract, not 1/16. That's a common mistake. I change the insides of these parentheses by 1/16. I change the whole value of this by 2 times 1/16. So I'm going to subtract 2 times 1/16. Does everyone understand why it's 2 times? Because we added 2 times 1/16. So we're going to subtract 2 times 1/16. Everyone understand that too? Now, if you did some completing the square exercises when you're supposed to, like 2 or 3 weeks ago, you're going, Mr. Miller, we've had this. Please move on. I hope half the class is thinking that. No, I hope all the class is thinking that. Right. All right, so what happens? This is 2 times 1/16 is minus 1/8. Okay. 3 that's going to be minus 24/8. See what we did? Get a common denominator. That gives us a minus 25/8. Okay. What about this stuff? Well, why do you complete the square to begin with? You complete the square to begin with to make an expression into a perfect square. So our goal was to make what's inside the parentheses a perfect square. And so inside the parentheses is now going to be 2 times, and those parentheses are now a perfect square. So you factor that. Now that is a little bit ugly to factor. But I told you to pay attention to this 1/4 here. That will help you factor this, because what you have is this is going to be x plus 1/4. That value there goes in there. And if it were a negative there, if that were a negative, you'd put a negative here. We got that? If this were negative 1/4, you'd have x minus 1/4. And that's all squared. Okay? That is very important. Now, we're not going to do anything else. When we did this to solve a quadratic equation, we had several more steps to do. This is all the steps we need here. This is f of x. Now, why is that enough? Because we're going to graph this. Well, why is that enough to graph? If I go back over here, this one, you remember some things we graphed here? I got homework, let's say. Our example now in chapter 3 is exactly like this homework problem right here. Right? Now, you didn't have to graph that, but you know how to interpret that now. You know that this minus 1 is a shift. What kind of shift is the minus 1? To the right. To the right. A la derecha. A destra. Migi. That's my 2 Japanese words I know are migi for right, hidari for left. Migi, hidari. I learned that driving around the island of Corsica with 2 Japanese, not Corsica, Sardinia, with 2 Japanese businessmen 15 years ago. That was a blast. All right. So this is a shift in the positive direction. This is a substitution. That is a shift down. This is a vertical stretch. This one turns out to be a horizontal compression. There's 3 here. Y'all did those, right? Shake your head. Okay. So if you did those, you'll know what to do with this. This is a horizontal shift in the negative direction. Counterintuitive, right? If it's horizontal, counterintuitive. This is a stretch. This is a vertical shift down. Okay, you know how to graph that. That's why we completed the square. So how do I start? I'm going to start like we've started everything, every graphing problem we've ever done in here so far, and every one we're going to do probably. We started with the plan, right? How do you do the plan? Rubber band. You start with something whose graph you know from the library of functions. So this is going to be step 1, y equals x squared from the library of functions. That's going to be our first starting point, okay? Number 2, I'm going to move it over a little bit. We have to turn that into that. How would I do that? I recommended starting with the stretches and compressions. In this case, I would do this 2 next. So my next step, y equals 2 x squared. That is a vertical stretch by a factor of 2. Questions? Stop me. Throw something at me. You missed it earlier, man. I totally almost creamed her with a stapler earlier. It was terrible. 3. I would do one of those shifts. I like leaving the vertical shift for last, but that's a personal little quirk, okay? So let's do the 1/4. 2, parentheses, x plus, you know what? Time out. X plus 1/4 squared. Now notice all the x plus 1/4 is in red because it is being substituted. It is being substituted. So this is a substitution. This is shift right 1/4. So it's going to be shift right. No, did I say right? Oh no. Typo. Left by 1/4. There we go. And then 4, we're going to go right here. This minus 25/8. That's down by that amount. Okay, that's down. That's a downshift. All right. Just like your dad's 5-speed truck. You can't buy a 5-speed truck anymore. Okay. All right. So now we're going to do those on this graph. Now, on the test, I'm probably going to give you 2 graphs for some of this. One to put your original work, one to put your final answer. Okay. All right. A couple more things we can do, though. We know we can do intercepts. And I'm doing this also to help you review for the exam. We know the y-intercept is the -3. So down here, -3. Okay. X-intercepts. How do you find the y-intercept of any function in the universe? Plug in 0. How do you find the x-intercepts of any function in the universe? Solve the function equal to 0. Right? Well, I could solve this equal to 0 if I wanted, but I don't want to. Oh, by the way, now, since we adjusted, we got our bones back in line, this last function here is exactly the same function as we started with. It has exactly the same graphs. The same graph has the same value for all values of x. If I plug x equals 10 in here, I'm gonna get the same thing as I get if I plug x equals 10 in here. What this form serves me when I go to graph it, right? So to get the horizontal intercepts, I'm gonna factor this. If it factors, let's see here, 2x, x. Let's do a +3 -1. Does that work? I FOIL it back out. Let's see if it works. This is 2x squared is the f. The outside is -2x. Inside is +3x. That gives me a +1x. 3 times -1 is -3. That's a happy meal. Okay. So this gives me a factorization. I'm going to set that equal to 0. And you know the zero product rule, right? The very first slide of the semester kind of thing, first example. This is going to give me x equal -3/2, x equal to 1. Those are the x-intercepts. X equal to 1, x equal -3/2. Right? Right? So you pretty much see how this is going to go already. But let's go ahead and do some graphing here. Let's follow our plan. Our plan starts with y equals x squared, right? So I'm going to have that. I did something I don't normally do. I label these axes. I don't normally do that. I do it only in the slides. I try not to on tests. But my first function is that. Oh, by the way, if you've got your plan up here and the plan steps are numbered and you should only do one transformation per step, you can just put the number next to your graph, different graphs on here. So that's your first one. Second one is that vertical stretch. So everything goes away by a factor of 2. That is 2. 3, 3 is a shift left by a quarter. That ain't much. The shift left by a quarter, you're only going over this far. So my third graph moves the red graph to the left by just a little bit. That's 3. And last, my fourth step, I move that down 25/8. Now 25/8 is a little bigger than 3. So I'm going to move this down by a little more than 3. Y'all tracking? This step right here, this -25/8, it moves that green graph down. And it's going to be what? It's going to go to, now this point right here is the point -1/4. That's going to go down to like right here. That's the point -1/4 -25/8. That's going to be the bottom of my parabola, called the vertex. That's going to be the vertex of my parabola. And then I have all these other points on here to go by. So this is nice. It's going to go like this, through that intercept. Through that intercept, bottoms out there and goes up. And this is graph number 4. And so what I'm going to do there is I'm going to make that bold. Right? Because that is our final answer. If this were an actual exam, you'd be provided another graph on which to display your final answer, right? Okay. So this is the graph of that polynomial function, or that quadratic. I'm the first to tell you I bombed a lot of extra territory here. One was to review. In fact, that was the main reason, to review, right? What did we review on this that would be useful on the test on Friday? Completing the square. Almost every kind of transformation we did. We didn't do any reflections here, right? There's no reflections there. But we did shifts and stretches. So that was reviewed. We reviewed how to find intercepts. Plug in 0, got the -3. Factor, set the factors equal to 0 to get the x-intercepts. So that was reviewed, right? So there was this covered several points on that other slide. This other slide right here. Right here. Several of those points are covered in that example. I hope it helped. That was my goal. Any questions? Any questions? All right. Okay. Going once, twice. The vertex of a quadratic function. This is really handy. You see this? No, you see this down here? -1/4, -25/8. You see that? There's formulas for that. You don't have to go through all the shifts to do that, to get that. There's a formula, and the formulas are right here, right? The formulas are right here. If I have a quadratic that's in standard form, ax squared plus bx plus c, that's a quadratic function. Its vertex, this point down here at the bottom, is going to have the coordinates -b/2a, comma, f of -b/2a. Right? So find the vertex of this guy here. The one we just did, right? So I have A, my B here is a 1, C is -3. The x coordinate of the vertex is -b/2a. That's going to be a -1 divided by 2 times 2. Because A is 2 here, right? Right there, A is 2. And so that's -1/4. Look familiar? It's the same thing we got by using transformations. The y coordinate of the vertex is a little more involved because I have to plug -1/4 into the function. Right? So everywhere there's an x, I put a -1/4. So that's going to be 2 times -1/4 squared plus a -1/4 -3. Time for some fractions. If you can't add and subtract fractions, I mentioned before, you better get to chapter R. There's a section in there on that. And brush up on that quickly. Pronto. Ahora mismo. So this is going to be 2 -1/4 squared is 1/16. -1/4 -3. Two times 1/16 is an 1/8. 1/8 minus a quarter. A quarter is 2/8. So that's minus 2/8 minus 3 is 24/8. All right. Okay. All right. One-eighth minus 2/8 is minus 1/8. Minus 1/8 minus 24/8 is minus 25/8, which is the same as we got by transformations, right? Ergo, the vertex is minus 1/4 minus 25/8. All right. Whatever you do, don't just leave it like this on the left. Because over here on the left, you haven't told me what the vertex is. You've done the work, but you haven't said what the vertex is. I've got to see an ordered pair somewhere for full credit, right? So be sure you answer what's asked in a problem. That's a good idea, by the way, in all classes, right? That's a huge thing on standardized tests and on every summer I grade AP statistics exams. You know those AP exams, you may have had them at your high school, right? I'm a grader on that. I go, oh no, they did the work, but they didn't know what to do with it once they got it. They memorized the process, but they didn't tell me what the vertex was in this case, right? Right. Be sure you answer the question. Questions on that? Here's another one to graph. As if we haven't graphed enough already. Have we graphed enough already? No, more graph. This one's a little trickier. You remember I said the last one didn't involve a reflection? This one involves a reflection, right? But because of that negative, right? So this is going to have another little twist to it, right? How would we start? F of x equal. How did we start last time? We factored up front whatever was in front of the x squared, and we factored it off the x squared term and the x term. So minus 1 is getting factored off of these first two terms. That's going to give me x squared plus 3x. Leave a space, plus 2. And as I said last time, all we've done there is rearrange the furniture. We just rearranged the stuff that was in the original function, okay? And so you're factoring the minus 1 off of the first two terms. You can only complete the square on expressions that have a 1 in front of the x squared. So we had to get a 1 in front of it. There was a minus 1 in front of it, so we factor it off. Go a little bit faster. You take what's here, multiply by a half. That gives you 3/2. Remember that value. Square it. 9/4. And that goes back here. Plus 9/4. Now let me tell you what the most common wrong answer will be on this problem. Plus 9/4 there, minus 9/4 here. Why is that wrong? Okay, and what should this be here? I added 9/4 there. Shouldn't I subtract 9/4?
The negative one in front.
Yeah.
Ding, 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 ding. Yeah, I added a 9/4 inside the parentheses. But just like the 2 multiplied it last time, this time this minus 1, right? Little rascal, that minus 1 multiplies the 9/4. So really, I changed the value of these parentheses total, including the -1, by a negative 9/4. So out here needs to be plus. Plus. All right. I hope that helped. All right. That's a common type of mistake. All right. And just like we did last time, we got to do some fractions out here. So I'm going to do let's see, 2 is 8/4 plus 9/4. That's going to give me 17/4 out there, right? And then the reason why I completed the square to begin with, was to make it the expression inside a perfect square. So this is going to be x plus or minus what squared. This thing. Remember I told you that? That goes right here. Plus 3/2. That number winds up going there. And again, if that happened to be a -3/2, it would be -3/2 inside the parentheses. And this is ready to graph. You know how to graph those. Okay? You know how to graph those. In fact, that should be the homework coming up. I should put a homework right after this. Oh, I got it. I should just make that a homework. All right, now, how do we graph it? The plan, right? Oh, Mr. Miller, I'm so sick of the plan. Oh.
¿Qué pasa?
Over there. Stay. Right. And don't tell me you don't talk to your applications on your laptop, right? You ever talk to them? What? What did you do that for? It's a spreadsheet or something, right? The spreadsheet's going, oh, I'm sorry. Okay. Start with a plan. Once again, we have x squared, right? And no, they all don't start with y equals x squared. Your homework didn't start with that. So this is, you start with number 1, y equals x squared, and that is from the library of functions. Number 2, what do you do next? I would do this -1 next. Now, it'd be even more interesting if that were like a -3 out there. Because a -3 out here, and I shouldn't make it that way. A -3 out there, ladies and gentlemen, is not one transformation, it's 2. If this were, don't change your paper, but if this were a -3 right there, that is a vertical stretch of 3, and then its minus is a reflection about the x-axis. So a minus number out there is 2 transformations. And you remember I strongly advised you, I'm not going to take off. In your plan, if one of your steps is actually 2 transformations, I'm not going to take off for that. I'm going to want to see your plan. And I'm going to want to see your graph that corresponds to your plan. Because you can have the right plan and the wrong graph. Right? However, if you do two transformations in one step on the plan, I don't recommend it, but if you execute it right on the graph, that's cool. That's cool. So anyway here, the -1 is what I would do next. So that's going to be 2. Y equal minus x squared. And that is a reflection about the x-axis. Right? Reflection about x-axis. Okay? Reflection about the x-axis. Now we got these 2 shifts. This guy here is a shift Hidari. A la izquierda. Right? So this is going to be 3 y equal minus x plus. And that's going to be shift left. The plus shifts it in the negative direction. Counterintuitive. Last, the 17/4. And that is a shift up. Okay. And I'm going to do what I did earlier. I'm going to move this down some more. All right. All right. More review for Friday. All this is review, right? All this complete the square review, reflections review, transformations review. Right? So it's a good unit to start chapter 3. I didn't pick it. It happens to be what's in the book. Right? So y equals x squared. Once again, I see the way I do this, I know those points are on y equals x squared. -2 goes to 4, -1 goes to 1. So I just put some quick dots, and I will, right? That's graph number 1. Graph number 2 is negative of that. So that reflects it down, right? Super Bowl Sunday, right? The reflection is good. No, it's down. That's not even a joke. Right, so it's going to go this way. Anybody watching the Super Bowl? You watching the Super Bowl? Okay. Here we go. Oh, I missed that point a little bit. You get the idea? That's number 2. Number 3, shift. Shift, left, 3/2. So that gets shifted. The vertex goes from there to here. Right? That's -3/2. You should label it. And that's going to look like that. I shifted left by 3/2. Right? That's number 3. Number 4 moves that up. Up by 17/4. 16/4 would be 4, right? So 17/4 is a little bigger than 4. So this vertex is going to go up a little bigger than 4, right there. And so you're going to label that, right? -3/2, 17/4. And it's that green graph pushed upward. So it's going to look like this. One thing, I do know the y-intercept real quick. It's 2, right? So it's going to go through 2. All right? And that is 4. That's your final graph, which normally I'll give you a separate graph on which to put that, okay? All right? We'll leave that there. Here is the graph on the calculator. You should be able to find that maximum, right? And that is a homework for, I guess, Monday. All right? Monday. All right, I'll see you Friday. I'll be here a few minutes early. Come by my office. Got my office hours over here. If I'm here, I'll help you. Right? I had some people at Spark on Monday. That was good. I think I had the most of anybody. Right? My different classes. That was good. So let me know how I can help you do your best. See ya. See you, Devin.